Hello, my name is Bradley Van Dam, and I will be doing exam chapter 28 for problems 2.1 through 2.4. So let's get started. For question 2.1, we're given information proton with a charge of positive 1.6 times 10 to the negative 19th coulombs. Sorry for the background noise. And that is at the origin, it says, so 0, meters. And given the velocity is 2 times 10 to the 5th meters per second in the positive, oh, actually I'll just say in the positive x direction. So it wants us to find the magnetic field B that this proton produces at a certain point, being x equals 0, y equals 1 millimeter, and z equals 0. So let's use the equation here. So we have magnetic field, which is what we're looking for. It's equal to, so we have velocity, distances. Okay, so we're going to use mu naught 4 pi multiplied by the charge Q times velocity, and then cross product with the position, all over r cubed. So let's plug in some values here. So the mu naught is going to be 4 pi times 10 to the negative 7th. This multiplied by 1.6 times 10 to the negative 19th, which is then multiplied by the what is it here? Oh, sorry, I kind of messed it up. So over here I had it separately. So 4 pi times 10 to the negative 7th divided by 4 pi as a fraction multiplied by the charge of 1.6 times 10 to the negative 19th multiplied by the the cross product of V and R. And so our R in this case is going to be the, let's see here. Okay, yeah, so we plug in 2, 5, and that's in the positive X, cross product with our R that we were given from the problem, which is essentially x equals 0, y equals 1, and z equals 0. But it's a millimeter, so let's convert that to, let's see, 1.10 to the negative 3rd. And that is going to be in the positive y direction. That's all divided by the 1 times 10 to the negative 3rd, and that's cubed. And since we have, I'll do a little illustration, x, y, z. So this is the positive direction, so x cross y is going to be z. So we have positive x, positive y. That's going to give us a positive z result. So the magnetic field will be in the B coordinate. So, yep. Okay, so let's do that out here. Oop. 1.6 multiplied by the cross product, so 2/5 multiplied by 1 to the negative, or 1 is 10 to the negative third. That's all over 4 pi times r cubed. Gives us 3.2 times 10 to the negative 15. That is for part A. Part B asks us to do the same thing, but I won't rewrite it for part B. I will write the solution however over here, because it's going to be doing the same for both parts B and C, I believe. Yes, so it's going to be for both parts B and C. We're going to be doing similar procedures. Actually, and for part D, we're going to be doing similar math here. So I'm just going to leave this all here. We're going to use the same, I guess, like framework or idea behind using the same equation, but we're just going to manipulate the different distances that it says, yeah, for the proton. So, so for part B, we are given now a new position. So x equals 0, y equals 0, and z equals 2 millimeters. So now instead of 1 millimeter, it's going to be 2 millimeters, and it's in the positive z direction. So we have a x cross z, so that's x cross z, so it's going negative, so it's going to give us a negative y value. And yeah, so we can just change that one small little thing from the problem instead of having to rewrite it out every single time. Times 2. That gives us, it shouldn't be 6.425. What did I do here? So this is 2 millimeters, yep, times 2, 6.4. Okay, let's actually just write it out in this case then, because I'm sorry, I seem to get it mixed up. $19 times 5th, and that is, yes, that's in the x direction, so I'll say x hat, and then new position is 2 millimeters, so 2 times 10 to the negative third, and that's in z, all divided by, oh, I see what I didn't do. I forgot to change the denominator from 1 millimeter to 2 millimeters. There we go. So we get, yeah, cubed. And that gives us, well, actually, first let's observe here. So we have x cross z, like we said, so that's going to be negative y. So the answer here for part B is going to be that it's negative, and then 8 times 10, or we can, 8 times 10 to the negative 16. Okay, so, and then, yeah, like I said, for part C and D, it seems we're doing the same. So, oh, okay, I remember this one. So it's part C wants us to find the magnetic field again. that this proton produces at x equals 1, y equals 0, z equals 0. But we actually don't even have to do any work out here, because if we just observe what the cross product's going to be, if we have x cross itself x, it's going to give us 0. So for the position that they gave us, or I guess any future position they give us where there's only an x component, then it's going to be 0. So for part C, it is going to be 0. I'll just circle that and say C, and that's because of the x cross, or being the cross product for itself, is going to give us 0. So that's part C. And part D ask us again the same thing, but this time we are given this one actually I'll go ahead and write out. This one is a there's not just one, it's not just one dimensional, so there's an x and a y component. So there's a position x equals 1 and y equals 1. So again, same procedure, times 10 to the negative 7th over 4 pi. Again, everything is staying the same except for the position that we're manipulating in the cross product. So we have x and cross product of 1 plus 1 in the y. And that is all over. That would be new radius, which would be, oh, no. I'll just say 1 plus 1 in this case, because it's, but I'll just say, well, actually, essentially, it'll just be 2 times 10 cubed. So go back over here, 2 there, yep. Essentially, we can just, let me see. No, we have to add that in there, so we can't just do that change. Oh. Plus it should be giving us the same. Oh, I see why. So again, I have to observe which coordinates we're going into. So this is x cross x, so that guy will result in being 0, again similar to part C, because x cross itself is 0. So now we have x cross y, so that's going to be z. So essentially we are only, I didn't really need to do this anyways, we only are going to be dealing with, hold on here, oh. It doesn't look right either. It's supposed to be 1 plus 0. Let's see. Okay, let's see. 1, 2 cubed. Oh, okay. So that's what it was. Times 10 to the negative 15th. And that is for part D. So now let's go to question 2.2. So it says a proton with a charge, so Q equals 19th again. On the XY plane, on XY, actually I'll denote P and E for the proton and electron because they give us charge for an electron here. So a negative 1.6 on the XY plane again, and then the speeds of both of them, which are actually just the same. So I'll just say comma VP comma E is 3.2 times 10 to the 5th meters per second. And then corresponding to the velocity of the proton, we'll say, the problem says that's in the positive y. Positive y, x equals 0. And then for the electron, in the negative y, x equals 0.004, actually, not just 0.04. Okay, and so it wants us to find, where is it? Find the magnitude, or no, at the instant when the proton and electron are at their closest approach, what is the magnitude of the magnetic force that the proton exerts on the electron? So we can use, let's see. So the equation we're going to use, so essentially we're looking at F on E. And so that force equation is going to be Q of the electron, so QE, and then VE cross product with the magnetic field. So we're going to have to solve for the magnetic field before we solve for the force. So, and again, that's denoted as BE. I'll just do a little square. So to get B of E, or for BE for the electron, we have to do the same form over here. So 4 pi times 10 to the negative 7th divided by 4 pi times the charge times the velocity cross product with the position all over position cubed. So let's plug that in. So we have negative 7, 4 pi times the charge, which is for the electron negative 1.6 now, times the cross product, so 3.6, or sorry, 3.2, and that is in the positive y, so I'll say, I'll just write it above from now on, so positive y, and this, actually don't need to do that, I'll just say cross, and then we have the position, which was x equals 0, so we just have 0 right there. Yeah, and I'll just say x hat, all divided by the, what is that? Yes, that 0.004 cubed. So let's do that out. Times negative 1.6 to the negative 19th Okay, so in that case, it would just be the 0, so that gets rid of itself. So then just times 3.2 times 10 to the 5th. Oh, I forgot to put the, what is it here? Nope. Okay, so that is, and then we get the B of E, which is negative 3.2 times 10 to the negative 16th, and then the, what have you, yes, and that's going to be in the Z direction, so Z hat. Plug that back in here, so we can now solve for the force on E. So we have a charge, which is negative 1.6 times 10 to the negative 19th, multiplied by the cross product now between the velocity. So what have you here? Okay, so yeah, we noted that it's negative, or in the negative y direction for the velocity here. So, yep. And yep. What was I plugging in? 3.2. 5th in the, yeah, so it's negative y. And then the position, or not position, sorry, what we had just solved for here. So negative 16, and that's Z. So then we're going to close it up. It gives us, it's going to come out as positive 1.64 times 10 to the negative 29th. That is newtons. That is for part E. Okay, this is at instant when the proton and electron are at their closest approach. Says, what is the magnitude of the force exerted on the proton? So F on P. So this is actually going to be, I almost forgot about this. This is actually going to be the exact same as the force on the proton as the electron. So that guy is going to be for parts E and G. Actually, say E, F, G, and then H as well, because those were all captured in those questions. E, F, G, and H. And then, okay, so that's for 2.2. 2.3. So we have a segment of a wire centered at the origin. So I'll just say, excuse me, wire 0, 0, 0. And length, excuse me, 002. And it carries a current of 6 amps in positive Y, and the magnetic field wait, I think it says, okay, so it wants us to find the unit vector from the wire segment to this point. And we are, magnetic field do this. Yeah, so we're not given the actual magnetic field value, but we are given the fact that it is measured at see here, 340. So x is 3, y is 4, z is 0. Okay. So here we're just gonna address the differences here. So we are going to, in the x hat, so we have 3 minus 0 plus 4 minus 0 and then I just won't even write the z because it's 0 minus 0, so I'll just say plus 0z. So that gives us 3x hat plus 4y hat. So that gives us the position vector. Now we need to solve for magnitude. So we could solve the unit vector. So we are given 3 minus 0 is for x hat squared plus the y component, 4 minus 0 squared for y hat. So that's, let's see here. So 3 squared, 9, 9 plus 16. So square root of 25, so that's 5. So magnitude of 5. So we have the vector, magnitude, and now we can solve for the unit vector, which is r hat, which is what the original question was asking for. Yes, so we have to do the vector over its magnitude. So that's 3 plus 4 all divided by 5. So it'll give us, I'll just leave it in fraction form. So 3/5 x hat plus 4/5 y hat. And that is the unit vector for part I. And part J wants us to find the magnetic field at that point, or at this point. So we can use, again, a similar formula. Slightly manipulated, actually, in this case, because... Okay, yeah, so we want to do mu naught 4 pi times the current times the cross product of the length and the position all over the magnitude squared. So that's, again, 4 pi times 10 to the negative 7th times, and then the amps we're given that runs through the wire is 6, so 6 times, and then 0.002 and that is, actually I don't think I wrote it down here. They're supposed to give us the positive, where does it say? Okay, so it's positive, positive y is what it was. I did write it out, actually. So y hat cross the, sorry, what was it I was just thinking of? Let me think here. So it's oh, okay, it's not the vector, it's r hat, so the unit vector. So multiplied by, and then that 3/5 x, 4/5 y. So we know anything cross product with itself is going to be 0, so that 4/5 y hat goes to 0, and then we're just left with the y cross x, so y cross x is negative z, and that's all divided by the magnitude squared, so that's just 25. So let's do that out here. Nope. Six times 0.002 times 3/5. And that, yeah, so that gives us positive 2.88 times 10 to the negative 11th, but since we just said the y cross x is negative z, our answer will be negative 2.88. That is for J. And then the last part is part K, which is we're given the information. Actually, let me just do a little separation here again. 2.4. So similar to 2.3, we're given wire at origin and its length. This time it's 8 millimeters, so 0.008 meters, carrying another current, which this is different, so I equals now 4 amps instead of 6. And that is in the positive Z direction. Okay. So this one, or let me think here. Charge, so length, the current, the direction, find the magnetic force that this segment exerts on the electron, charge of negative at 0.1.25. Okay, so we're also given, I'm not sure if that'll be useful, but I'll still write it down. So charge negative 1.6. And then at point, so this is 1.25 meters, and then y and z are 0, so 1.25 comma 0. And then velocity 310 to the 5th meters per second, and this is in the negative x direction. Okay, so it wants us to, okay, yeah, let's do this here. So the magnetic field, mu naught, we're gonna do the same process as before. cubed, sorry. No, we didn't do, yeah, we did squared, sorry, not cubed. So equals, again, you know the drill. Four times. .08. That is Z. 1.25 Y. 25. Okay, so I just cleared it. Okay, so that is, putting all that in, that is 2.048, and then times 10 to the negative 9th, and that will be in the y hat direction. So that wraps it all up. This is exam chapter 28.